So in this video, I'm going to reflect on my research journey and talk about how my current project fits in. So I've been doing research since middle school, and all my ideas come to me spontaneously. I would just pick whatever was in front of me, ask a question about it, and try to answer it. So since middle school, I've always been interested in neuroscience, but my research didn't start with neuroscience. So in 7th grade, I did a project about air pollution, where I drove around Texas, plucking leaves from different locations, and then I came home, and excited for an excuse to use my light microscope, I would look at them and search for air pollution. Then in 9th grade, I did a project about diagnosing osteoporosis by buying chicken bones from the supermarket and dissolving them in acid to mimic the disease, and then passing electricity through them to measure the resistance and diagnose it. So I've always had fun with my research. I would steal my mom's tea kettle to melt together chemicals and name all my electrical instruments. And my garage would always be a mess with all the materials of my last experiment lying around. But then I started to wonder, this thing I do in my garage, this thing that I've grown to love, is it actually real research? I always imagine real research being working on groundbreaking cancer research in a lab setting with fancy machines. But then I realized that it doesn't have to be that way. Research is nothing but finding a problem you like, thinking of an idea, and testing it out. And I don't consider myself to be a genius in any specific field, but what I can do is dabble a little bit in everything that interests me and then try to connect things together. I consider my biggest strengths to be stringing together topics from completely different areas and making connections that nobody has made before. All my projects so far has been extremely interdisciplinary. When my problem is in one field, I will search for solutions in a completely different field. And that was the case for this project. The problem I wanted to solve was how the brain works. What fascinates me the most about that is that the brain is made of the same elements that we see in rocks and the air. And these elements just happen to be arranged in certain building blocks, the same cells that you see in a plant or a mushroom. And yet, these simple components are able to give us this incredible experience of consciousness, to think, feel, build a civilization, and ask about our place in the universe. So what's the link there? At what point do all of these cells turn into all of this? And that was the big question I wanted to solve. How does the brain work? But I knew when I had this question that there's no way a high schooler can realistically answer it. It's a big question that's very fascinating, but it's so complex and abstract. Not only do I not have resources or a lab, but I also had no clue where to start. And then when I learned about the canonical microcircuit theory, I thought, this is it. This is my ticket to getting closer to understanding how the brain works. And what's incredible about this is it seems like such a simple problem. It simplifies this very complex, abstract question of how the brain works into just how can we figure out this one simple computation, and then we can scale it up. And as has been with all my projects so far, I didn't search for a solution in all the usual places. I was interested in quantum computing around the same time that I was brainstorming my project, and I thought, has anyone drawn this connection before? And the answer was no, so quantum computing was a completely unexplored direction in this field of research. And what was more exciting was that I can do this project right now, myself, at home, on my own laptop as a high schooler, and I don't have to wait any longer. I was so excited to get started. And this project tested me the most out of all my other projects, since as a person whose primary work has been in biology and neuroscience, or primary skill area has been in biology and neuroscience, seeing the code that was complicated and foreign coding languages was frankly very intimidating. I would look through papers of containing very complex math equations from quantum computing and machine learning, and I would often get discouraged when seeing those, but I stuck with it and made sure and assured myself that the more I learned about this, the better I would get. And then 9 months later, I am here. So I think of this research as the culmination of all my research dreams since middle school. I can finally apply all the research skills I've learned throughout all my middle and high school years into the problem that I've really wanted to solve all along. And I consider myself extremely lucky to have been able to do that. Next, I plan on reaching out to researchers at Baylor who made the original dataset that I used and hopefully collaborate with them on my new model. I also have been trying to pitch my idea to the internship that I'm working at with Johns Hopkins right now to do a physical implementation of our current project about visual recognition so that I can test my model on it. And I'm also in the works of publishing it in a scientific journal in computational biology. So this project is far from done, but I can't wait to see where my research journey will take me next.